square yg cos square lambda. So this is also correct. Anywhere you can stop. So by using the data, you can easily substitute in this formula and we can get the answer. From this, due to rotation of the earth, so G value changes from latitude to latitude. Latitude changes, G value changes. Gradually, it decreases or increases. See here. See, suppose here this equator, from equator to pole, G value increases or decreases? Increases. Why? Because here latitude is increasing, therefore this value will decrease, totally G dash value increase. So that is the effect of this. Now, if you ask me any important topic, it is not possible to discuss all general topics. Exactly. Yes, that is the reason. So here also, due to rotation of the earth, G value is less at the equator. At the same time, due to the shape of the earth, G value again less. So these two effects, because of these two things, G value is minimum at the equator, maximum at the pole. So not only one reason, there are other reasons. Okay, considering all the other reasons, you can easily find these things. Now, that is all. Next, which topic you want? It was tell me the topic if you feel anything. I will try to explain. Shall I add this one?
Seconds.
Okay, right. If you still have any doubts, please you can ask me regarding this topic. So all simple things I don't discuss, only tough ones. Okay, which you need. You can ask me. Many degrees subject. Different topics. Okay. Sir, carry on. I'll continue. Okay, right. What about this, sir? This over? Shall I continue? Right. Next, see, sir. Sorry, sir. Next one. Potential. I like the potential. Gravitational potential. See, gravitational potential. See, what is gravitational potential? See, for potential, in any chapter, whether it is electric potential or gravitational potential or anything, so definition is same. The work done by external force, that is really important. Work done by external force in moving a unit mass from infinity to a point in the gravitational field. This is the Pakka definition, 100% definition. Which force is doing this work? External force. Means what? We have to do work in bringing a unit mass from infinity to a point. So here,
so that is constant velocity of this energy same.
yeah. That slowly you have to move it with constant speed. There should not be any acceleration. Slowly you have to move it. Not randomly. Slowly you have to balance it. Why? Because there should not be any net force acting on it. Is it clear or not? Net force should not be there. Net force should be zero. Whenever net force is zero, it is moved with constant speed and slowly. It is possible only when it is moved slowly. What is the meaning of that? For example, see this is a body of mass, say some m. Okay, and I want to find potential, gravitational potential at a point P. Okay, P is our one. what is gravitational potential at that point. What we have to do? See, to understand this, you should know what is potential difference. Potential difference. Okay, between 2 points, say this is point A and this is point B. Okay, so your potential is BA and this is potential VB. What is the potential difference? Just you have to move the unit mass from B to A. Means what? Work done in moving. Work done in moving. A unit mass from B to A. B to A. You have to move. Okay, by mass. This is potential difference. How to find potential difference? Potential difference at final point, say I want potential difference between A and B, BA minus B. If you want the potential difference, you can write this VAB. Right. Alright. BA minus BB means what? I am bringing a unit mass from B to A. Okay, B to A. For that I am doing some work. The work done in moving a unit mass from B to A. B to A is important. Very specifically, you should remember this one. B to A. Then you will get BA minus BB, not BB minus BA. So why? Because final minus initial difference. You should find that potential, especially potential. Difference means numerically that is different. What is the difference between 10 and 7? 3. 7 and 10, 3 only. Not final, not initial. But in the case of potential, final minus initial. So initial point is B, final point is A. So what is potential at final point? BA. BA minus BB. But work done is from B to A. So work done in moving unit mass from B to A. This is very important, otherwise you won't get any answer. So
High potential minus low potential.
no, not like that. Not like that. This is the thing. Not like that. Final minus initial. Whether final is low potential or high potential doesn't matter. But final minus initial is the convention we should follow. That is the rule. Next here, you know the derivation of this potential at P is equal to minus Gm by. It is what distance is some r minus Gm by r. Do you know why minus? Anyone? What is the reason for this minus sign?
Force is upward to some distance.
Force is opposite to
Force mass.
right. See, position vector of this point is say r bar is in this direction, but the force is in this direction. Gravitation force. This mass attracts this small mass. Okay, this small mass is called test mass. Sometimes it is written m0. Test mass means it has no its own influence on other bodies. Very small. Okay, negligibly small. So this body is attracting this mass. Okay, this is force. The force is in this direction. That's why. But if you remember one thing, potential is also in the same direction. In this direction. Distantly. Potential is in the direction of force. Don't forget. Potential is always gravitation potential is always towards the mass. So here mass is this towards the body. Potential. Why? Because it is in the direction of force. So potential, force both are in the same direction. But why it is minus? Reason is opposite to the position of that part, the point. Okay. That's all. If you want derivation, very easy. Okay. Just you have to find work done. Work done is nothing but how to find work done? WAB. Anyone? Work done. Integration method, you know all these things. But in this standard, only the model. Okay. Next step. What is next step? This is the
Sir, GP due to circular ring, spherical shell, solid sphere.
is here directly any derivation circular.
Directly.
Okay, sir. Tell me.
పాయింట్ మాస్ తీసుకుంటున్నాం.
Yes, yes.
ఎర్త్ గ్రావిటేషన్ వల్ల దగ్గరకు వచ్చేసరికి అది ఇంకా ఎక్కువ అట్రాక్ట్ అవుతుంది.
Yeah, exactly.
అప్పుడు మన ఫోర్స్ పెరగడం వల్ల నెట్ ఫోర్స్ జీరో కాదు.
No, that force is not zero, but that force is not constant force. We have to apply variable force. That's why we have to integrate. For finding work done by external force, we cannot multiply F and S directly. Why? Because work done is applied as only for constant force. As you are moving towards the body, this force increases. So you should apply an opposite force. Also, should be increased. Okay, increasing force you have to apply. So to balance that speed, why? Because that force should be there. That's very very important. Say this is the body. Say from infinity. Say this is the infinity distance. The small test mass is being moved towards this. Okay. Why it is moved like this? What happens? This is attracting. This is attracting. So you have to. Yes, sir. Sir.
అట్రాక్టింగ్ అంటే
You are attracted. Right. Now see, you have to apply a force in opposite direction. This is a gravitational force. A gravitational force changes with distance. So while the body is moving towards the mass, okay, while mass, what happens? Gravitational force is why? Because distance decreases. Whenever the distance decreases, force increases. Then you have to increase the fractional. Why? Because F net should be 0. F net should be 0. If it is not 0, you cannot find electric potential, gravitational potential, not electric potential. Even electric potential has the same rule. It should be, suppose it is moving like this, you have to apply in the opposite direction. We are applying opposite direction. That's why work done is negative now. You apply opposite force. What is the displacement? Displacement is towards the body. But the applied force, external force is opposite. That's why you get negative force. You remember one thing, if it is attractive force or any attractive system, potential is negative, that's all. If any system has both attractive and repulsive is there, for example, electric charges, they may attract or they may repel. Like charges repel, unlike charges attract. Then you will get potential positive and negative. So electric potential may be positive or negative, but gravitational potential is always attractive. That's why it is always negative, minus C. Okay, minus C by R. Is clear?
గ్రావిటేషనల్ పొటెన్షియల్ కి రీజన్ ఇది కూడా చెప్తాం సార్. మనం ఆపోజిట్ డైరెక్షన్ లో ఫోర్స్ అప్లై చేస్తున్నాం.
Yes.
పొజిషన్ వెక్టార్ కి ఆపోజిట్
Correct. Next. So next topic. You have no time, sufficient time, that's why. Only selected topics I discussed, not all. Sir,
orbital velocity and
orbital velocity. See, the velocity of an object or a satellite in a particular orbit is called orbital velocity. See, this is Earth. Okay, this is the orbit. See, here, say this is a satellite. This is a satellite. So it is revolving. Like this is the Earth. So this is the radius of the orbit. Radius of the orbit. Okay, in which the satellite is rotating. Now here what is happening? Say this is the mass of the satellite, this is mass of the Earth, and this is the distance. Okay, here there are two forces acting on it. One is gravitational force, the other is centrifugal force. If these two are equal in magnitude and opposite in direction, it always traverses that orbit. Can't deviate, right? Both are equal. But you remember one thing, these two forces are not action-reaction pair. They are equal in magnitude and opposite in direction, but they are not at all action-reaction pair. That is very, very important. Do you know why? Anyone?
It supports. It is
Ah.
acting on
Both
one
are
point.
supports the motion of the object.
No.
It is acting on
Action
one
reaction
point.
should be across different
It
bodies.
is acting on one body.
One body.
Action and reaction they always act
Different
different bodies, but both are acting on the same body. That's why they don't constitute action reaction. Is it right? Now say if you equate these two, you will get the answer. Fg should be equal to Fc. This is m v naught square by r. This is Fg is how much? G m by r. Am I right or not? So this m and this m get cancelled, r get cancelled. So v naught square should be equal to g m by r. So v naught orbital velocity g m by r under root.
ఇక్కడ కూడా ఉంది. అది సెంట్రిఫ్యూగల్ ఫోర్స్
ఇక్కడ సార్ ఈటెక్ తో ప్యూర్ గా డీల్ చేసిన వాళ్ళు ఓన్లీ ఈటెక్
Okay, sir. Sir, we take
any associates here?
Present, sir. Hello. Okay. Small break is there.